Hello, this is Pinakin Advinkar and I am here to demonstrate the tasks which we had done as a part of milestone 2 of DevOps project. So we have worked on the iTrust part and we have done the building and testing part for the iTrust. So for that we had to perform following tasks. So as you can see, the first task was to set up build server for iTrust using Jenkins. Second was to generate coverage report. Third one was test case fuzzer, writing that utility, and the fourth one was writing a utility to detect useless test cases. So let me take you through all of them one by one. So first we'll see how we did set up build server for iTrust using Jenkins. So for that we have used Ansible playbooks. So Ansible playbooks helps us to configure a VM. So all the Jenkins setup is being done through Ansible playbooks. So I'll just demonstrate you how do we do that. Yeah, so as you can see over here, we have this iTrust Jenkins YML, which is our Ansible playbook. So we'll just start executing it. Yeah, so now what it is basically doing is it is configuring our VM. So it's installing all the necessary modules and it's installing Jenkins and all necessary setup is being done. So we'll have to wait until the setup is complete. So let's wait for it. So as you can see, it has installed Jenkins for us and it is restarting Jenkins after creating a job. So let's wait for it to complete. Yeah, so now as you can see, the setup is complete and Jenkins server is now available for us. So Ansible has also created a job iTrust for us on Jenkins, so let's just check it out. Yeah, so this is the Jenkins UI. So you can see over here that Ansible has created a job named as iTrust. So we'll use this for building our iTrust application. So that is how we had done the building part of the iTrust. Now let's go for the second task, which was generating coverage reports. So once this setup is done and once it is we can build the iTrust, then we have used this Maven plugin called as Jacoco. So this plugin basically uses JUnit test cases for the project and generate a coverage report for it, which includes line coverage, branch coverage, conditional coverage, etc. So it generates that report in the form of HTML format in which these statistical details are shown for each and every package. So we have generated this report and we have stored it over here. So you can see over here, so for every package it has created an HTML file, a report file. So you can have an overall report over here in index.html, and you can also view a package level report in individual package folders. So this is how we have achieved code coverage. Now the next task for us was fuzzing. So fuzzing is nothing but what we do in fuzzing is we introduce some random changes into the source code, and then after doing that we test that code against those random changes and we expect some of the test cases to fail because of those random changes. So that is how we achieve fuzzing. So what we have done is we have added certain mutations into the fuzzer, into the source code, and then we are committing that source code so that it automatically triggers Jenkins build with the help of post commit hook, and then Jenkins will build that project and then it will let us know whether the build was successful or not, and we are expecting build to fail since we have made some random changes into the source code. So let's just check it out. So first I will just start the script and then I will take you through the code. Yeah, so this is a fuzzing iterator.js Node.js script which we have written for fuzzing. So basically what it does is it internally calls fuzzer.js. So what it is doing is it is going to a particular package, it's going to the source folder where all the Java files are present. Then it is selecting some files randomly, and then it is applying some mutations onto those files, and then we are committing those files. So I'll just take you through the code till the time it is running. Yeah, so you can see over here, this is the actual logic for fuzzing. So what we have done is, whatever files are being sent to this, it is applying random mutations on it. So these are the mutations which we have used. So you can see this is a pattern matching. So for example, in this first one, we are replacing less than sign with a greater than sign. So suppose there is some if condition with a less than b, it will be replaced like a greater than b. So like this, we have done some 5 to 6 random mutations, and we are applying these mutations onto these random files so as to achieve fuzzing. So that is how we have achieved fuzzing. So what we are expecting is, we are expecting certain test cases to fail, and we are gathering those test cases into the failure report. So if you just see the failure report over here, so yeah, so you can see here that these test cases are failing because of the fuzzing effect, because we have made those random changes. So now let's just see what happens in Jenkins. So yeah, so now you are seeing that so this is how it works. So whenever new commits are made, Jenkins build is triggered. So our task was to do 100 iterations, like we had to perform 100 builds so as to get maximum failures in the test cases. So what we have done is, we have applied a loop over here, as you can see in the code. So yeah, so we have applied loop for our 100 builds, and every time it is doing some random changes to the source code in each iteration. Then it is doing git commit, and this git commit is triggering the Jenkins build job. Jenkins build job gets failed because of these changes, and then we are gathering the test cases which are failed, and we are saving it as a failure report. So this is happening for 100 cycles. So that is what it is doing. So currently it is on the second build, but to demonstrate that in the video, we have already done this part way before, because it takes a lot of time. So I'll just show you that part. So we had set up a separate machine for demonstrating this. Yeah. So you can see over here that we have done about 103 builds for this, and we have gathered reports from that thing. So the earlier report which I just showed you was from this machine. Yeah, so this is how we have achieved 100 build iterations. Now let's come to the fourth part, which is useless case detector. So useless case detector is basically what we are trying to analyze is, we are trying to filter out test cases which are not failing at all in any of these 100 iterations. So if we are making random changes for like 100 times, then we are expecting maximum test cases to fail. But if there are certain test cases which do not fail in any of the iterations, we mark them as useless test cases. So how are we doing it? So as I said before, we are gathering the failure report in which all the test cases which are failed in those 100 iterations are present. And before starting those 100 build iterations, we have already collected the list of test cases which are available in the JUnit testing, and then we are just subtracting the failed ones from the original list so as to get the test cases which never fail. So this is how we are detecting the useless test cases. So for that, we have written another script for generating this report, which is this one. So as you can see, it is taking up two files, all test cases and failure test cases, and then it is just filtering the useless test cases. So you can see the report for the useless test cases over here. So these are the useless test cases which pass in all the iterations for those 100 builds. Yeah. Yeah. So yeah, so for more details about those 100 builds, you can check these logs. So we have collected logs for each and every build. So you can go through logs over here. And for all the scripts we have written over here, and reports will have all the reports which we have collected: coverage report, failure report, useless test case reports. So that is how we have completed the task. Thank you.